Hello everyone. I hope you are safe and healthy. Myself, Rishit Khandelwal. So today I'm going to explain the discrete mathematics project on behalf of my group. As you can see on the screen, our topic is the use of graph theory in investing. If salary is your only source of income, then you are just one step away from the poverty. In order to survive in this rapidly moving world, multiple sources of income has become a necessity. Stock market is one such investment vehicle. But wait, it's not that easy as you think. You might have heard from many people that investing in stock market is risky. Well, what they say is true, and if somehow we can minimize the risk, it would be great. And graph theory is one such way to do so. So let's understand the mathematics behind it. First things first, what is a graph theory? As you can see on the screen, we have a rectangle ABCD in which the points A, B, C, and D are called vertices, and the lines connecting these vertices are called edges. Using this information, we will create an agency matrix consisting of zeros and ones as its element. But hold on, what do we mean by agency matrix? It is just a square matrix representing a finite graph. The zeros represents vertices and ones represent edges. In our project, edges will signify correlation. Don't worry if you don't understand it. This sentence will make much more sense as we move forward. Now let's discuss two terms. The first term, correlation. So what is a correlation? It is just linear relationship between two sets of data. Correlation coefficient, which can be calculated by the given formula, shows how much stronger or weaker the relationship is. Data sets whose correlation coefficient is close to 1 or -1 exhibit a strong relationship, whereas data sets whose correlation coefficient is close to 0 exhibit a weak relationship. The second term is called diversification. It is just a risk assessment technique that strives to have collection of stocks among which a negative move will be negated by a positive move. To diversify, we will be using correlation. So let's understand correlation better with an example. As you can see on the screen, we have two graphs. For a particular value of x, we have two corresponding values of y. One is represented using a blue dot and the other is represented using a red dot. Using the above formula that we mentioned regarding the correlation coefficient, we calculated the value for both the graph. Figure 1 has a value close to 1 and is exhibiting a strong relationship. Figure 2, whereas, has a value close to 0, which means it is exhibiting a weak relationship. And it can be also observed from both the graph. In figure 1, both the dots are moving together, exhibiting a stronger relationship between them. Whereas in the figure 2, both the dots are moving in the opposite direction. Well, that's it. That's what we needed. Stocks which are loosely correlated with each other. Let's consider the scenario. If we have multiple stocks which are strongly correlated with each other, it might cause a huge loss to us if one of them drops. So if one stock moves in negative direction and the other moves in the opposite direction, they cancel each other effect and minimizing our loss. So diversified portfolio consists of stocks which are loosely correlated with each other. So how we can do this? It's very simple. For every pair of stocks, we will be creating a correlation matrix and changing its element to either zeros and 1 using an input threshold value. And what is the threshold value? It is nothing but the standard deviation of the data set. The resulting matrix that we obtain is an agency matrix in which the vertices or the zeros represent stocks and the edges or ones represent correlation. So that's our project. However, no one can assure 100% certainty, but we still can reduce risk. Thank you so much, Professor Gupta and Professor Muttu, for this wonderful opportunity. Thank you so much.